Hello, everyone. This presentation will show you the journey of the largest engineering company in Peru through the different stages of projects applying BIM. As you can see in this quick review, since our beginnings, we have applied BIM in projects for mining and energy sections. Today, we will talk about 4 points in our journey through the BIM experience of Cumbra. We will start with the preparation of our BIM tools. Second, we will take a look at our goal to achieve the design of 3D models for engineering drawings. And we will share our BIM and supervision experiences. And we will show the importance and benefits of BIM for collaborative work. As a first point of the agenda, we present who we are and how we organize. Cumbra is a company based in Peru, Chile, and Colombia, with a presence in 12 different countries. This international experience allows us to acquire a way of working that accommodates the demands and requirements of the projects in our region. We have almost 20 years of work with the 3D models. In our beginning, we will implement the area of integrating engineering. And over time, we have been setting goals and incorporating our experiences to have a mature processes in the use of BIM. And in each project, we will incorporate our experiences and lessons learned to achieve efficient work. Our design and construction companies work their BIM applications according to the phase of the project, both considering the requirements of our clients. To start a project, it is important to know where we are in terms of dimensions, which help us to understand which software should we use. Our BIM method is applied in our 4 divisions. These 4 divisions are linked to the different construction sectors, such as industrial and commercial, mining, energy, and infra. We have technological options in BIM that we apply depending on the needs and requirements of a project, and we work on the platform that client requests. For example, as is in the case with industrial and commercial buildings, we could use Revit, and in energy and mining projects, we can work with any of the platforms such as SmartPlant, Aviva E3D, or Autodesk Plant 3D. BIM is applied in our design disciplines, such as architecture, civil, structures, electrical, processes, piping, mechanical, sanitary, and instrumentation and control. And in infra, we apply it in signaling and road safety, drainage work, quarry study, geometric design, structures, roadworks, soil stabilizations, and MTO. In this slide, we can see how the different BIM applications interact in infra. And it is important to know which tool we are going to use. But just as important is to know how much detail we are going to apply to our models. With the tools defined and with a large team of engineers, it is important to create a series of manuals and standards in order to have an organized work. We have a baseline workflows that can be accommodated to the different demands of the project and that can be applied according to the type of project. It is important to map our processes and take advantage of technologies such as BIM to incorporate them into the complete engineering process. Our implementation led us to create a library of recurring components used in our projects, and we will network them for access by all of our BIM users. Through an internal social network, we share BIM news, events, updates, improvements, and new applications, and also access to internal BIM manuals and courses. We also monitor our compatibility quality with Navisworks and online tax reports. It is important to know how we will be controlling our progress. For that, we have deliverables milestones with our customers, as well as the content that will be included. And in addition to these experiences, we add to our BIM processes our own developments for documentary control that we have successfully applied in most of our projects. Now we're going to see how BIM is applied in one of our important objectives as a design company, which is the preparation of BIM drawings. And BIM drawings refers to the linking of the 3D model with the 2D drawings. For us, this has been an important implementation and of constant updating with our disciplines. Here, a view of integrating BIM linking 2D with the 3D. And the 3D model ensures consistency, constructability, and coordination. Each specialty produces its deliverables in BIM. As we can notice in this BIM for electricity, BIM for architecture, BIM structural, detailing. As you can see an excerpt of detailing, we also can use this detail as a 3D part of the project and copy on all of the project, all over the project. And consider that the model has to be built in the field, having assemblies activities or spaces reserved for the operation. And now, after BIM for construction and design, when we apply BIM in supervision, we will have to complete vision of the creation, construction, and control of BIM projects. With BIM for supervision, we have been able to effectively control the progress and help the consultants and the clients to have a better understanding of the BIM scope of their projects. We rely on common data environments as well as in the controlled formats that we apply in our traditional projects. The common data environments allow us to better understand the advance produced and delivered by the consultant. And in the field, the supervisor can take their iPads and associate the photos of their incidents with the drawings and models and generate observations and quality reports. And now, BIM is collaboration. And as a great benefit, it is application to collaborative work. Multidisciplinary coordination occurs throughout the design process. As you can see in the slide, sometimes there is no time for formal meetings. Here, a picture of how we work in the office. And also, we can rely on technology for remote work. Technology allows us to improve our level of coordination of highly complex projects. Here you can take a look how we work in our office too. In construction, we use a BIM room for coordination with external consultants. In design, for coordination, we work in BIM rooms with our engineering teams. On-site, we implement BIM rooms for coordination with subcontractors and our BIM team. And getting to the end, a selection of projects in which we apply BIM, like this silver and gold plant that was made in E3D Aviva. In southern Peru. For mining, as you can see, the level of detail that we work on BIM. And here, a water treatment plant for a refinery in northern Peru. And here we use Smart Plant 3D. Now, a hydrogen plant in northern Peru. Hexagon Smart Plant. And here, a supply plant in Lima. And we use Plant 3D Revit, Civil 3D. Another plant, this is an acid and oil plant in the main port of Lima. Also, we use Civil 3D, Plant 3D, and Revit. And here, a power station in Central Colombia, where we use Smart 3D. And here, a crude oil storage plant in Central Chile. We use Smart Plant 3D, Civil 3D, and Revit. The most important cancer treatment hospital in the capital of Peru. Here we use mostly Revit. And it was designed, not only the model, design, and we use Revit. We work on the 2D with Revit and the 3D in Revit. Another hospital in central Peru. With laser scan, we survey of existence condition. And after that, we model and we work on animations for the understanding of equipment maintenance work. Point cloud survey and modeling of existing buildings to review the behavior of existing structures. We use recap, we use Faro, the Faro laser scan, and we also use the SAP 2000. Bridges and roadworks for central and northern Peru. More bridges. And here we have infra projects, such as roads, bridges, and rail systems. And the most important airport in Peru, and one of the largest in LATAM. Here also, it's linked, the 2D with the 3D model. So the deliverables are made from the BIM model, the 2D plans. And now we can have a view of what is BIM and what is what happens in reality. As you can see, the model looks just as the reality. And field applications that help the understanding of design and construction, and supported by triggers like QR codes that allow builders to visualize the work to be done. In conclusion, BIM has helped us to have predictability by anticipating problems during construction, quality of our deliverables with efficient coordination, and cost reduction with a better understanding of the project. And we can foresee inconsistencies before the work begins. And as you can see, our goal is to balance technology, processes, and people, making engineering and BIM the pillars of our project delivery. Thank you.